Okay, recording has started. So let me start off with some announcements, I guess. We usually do this screen at the start of class, so we're going to try to get through 1.2 and 1.3, and then we're going to have a quiz. We'll see. This might be ambitious of a schedule, but we'll do what we can. We're about 1 day behind on the schedule right now. I'm not too worried about it because this first chapter, there's a lot of material that you got to do relatively quickly. Then it kind of slows down a little bit. So we'll have time to make it up later on. And in any case, if we don't make it to like the very last section, it's not going to be a big deal. So we're 1 day behind on the schedule. Just keep that in mind. The readiness test is going to be due tomorrow. Okay, so to do the readiness test, what you do is you go on Blackboard, you follow the instructions that are posted on, like, instructions for readiness test, and you just do the readiness test. It's like, I don't know, how many questions is it? 7 questions or something like that? Those of you that have done it?
I think it's
10 questions? Okay, and if you get 70% or better, then they say that you are supposed to be well prepared for this class. Of course, you know, if you have errors that come from, like, you couldn't figure out how to do the parentheses correctly, or you didn't know how to type in square roots, well, that's why, yeah, well, I'll just leave it at that. Don't worry about it, is what I would say. But please do it. Okay, then homework 1.1 through 1.5 is due on January 25th. And then after today, you should be able to do questions 1 through 9 on that homework. I have office hours today from 3 to 4:30. So one thing that I really would like for all of you to do is this first section, this first chapter is really all review material that is going to be sort of used throughout the class. So if you have any struggles with some of the stuff from chapter 1, or if you don't remember all of this stuff from chapter 1 from your previous classes, I'd highly recommend you to attend office hours and chat with me. You know, I can help you identify where some of your missing parts are at and help you to kind of shore up any confusion there. Okay, so please come to office hours if you're confused by any of this, or just to come introduce yourself. That's also fine. Okay, so that's office hours, and then also our SI sessions are gonna be on Monday from 8 o'clock to 8:50 in close hip, right? That's what that stands for? Okay, close hip 350. So you got a Monday time, a Wednesday time, and a Thursday time. So if one of those doesn't work for you, probably at least one of the other ones does. And I'd highly recommend going to those too, because you know what? Who doesn't need more math practice? Right? Okay. Any questions before we start for today? All right, if not, then let's go ahead and form groups. Okay, and I'd like to start with warm-up problem A. This is a problem from the last, from the material on 1.1, so you shouldn't have to learn anything new to do it. So just give it a shot with your group members. I'll walk around and then we'll come together as a group and talk about it. Okay, does anybody, or does any group want a little bit more time to discuss? Okay, pretty quick one. All right. So who can help me with A? What do we think about A for function or not function? How do we tell if it's just an equation like this? I know it's always hard to break the ice and be the first student to speak up in class. Yeah, what's up?
I was just going to say it's a function
Mm-hmm.
because it's a parabola and it's just vertically shifted.
Yeah, exactly. So that's one great way to think about an equation like this is you've been trained, through your previous math classes to know that when we have equations like y equals x squared or like ax squared plus b, stuff like that, right? Those are all parabolas. So you could think, well, I know that this function has a graph and its graph looks like a parabola. And if I think about using my vertical line test, okay, so this yellow line is my pencil. I think about using my vertical line test. If I move it left and right, it's only ever going to intersect the parabola at one point, right? Okay, so that's a great way to think about part A. Thank you. What's your name again?
Eric.
Thank you, Eric. Fantastic. Okay, another way to think about it would be to say, well, think about putting in one number as an input, okay? A number like 3 or 7 or -1. No matter what, if I square that number and then I add 1, I get the same thing every time, right? So our function is consistent. I'm not going to have multiple outputs by plugging in a number for x. Okay, so that's two ways to think about it. All right, how about part B, going down? I don't know why these always go down first and then to the right. I feel like I always want to go to the right first and then down, like how we do everything else in life. Okay, who has something to say about part B? What do we think? Function or not function? Yeah, Mike?
It is a function.
It is a function. And your reasoning?
Because each input only has one output.
Exactly. We've got all different inputs here, right? So we don't have any repeated inputs. So we don't even really need to worry about whether or not we have one input going to multiple outputs, because we don't even have multiple inputs on our domain here, okay? So I'll just say, so this one, by the way, was yes. Vertical line test. This one was yes. No repeats in the domain. Okay, how about this one? For C. Yeah.
No, because they're all different inputs.
Yeah, it doesn't pass the vertical line test, right? We have multiple outputs for a single input, okay? So let's remember that the inputs on a graph, they all lie on the horizontal axis, right? So what we're looking for here is a point on the horizontal axis, so say maybe this one, such that, well, we see that there's actually 2 points on the graph of this relation, right, that correspond to that single point on the x-axis, or not the x-axis, but the horizontal axis, right? So this fails the vertical line test. Okay, and the last one, I think there's something we can notice here. Who can help me? Yes? Yeah, repeated inputs. And more importantly than repeated inputs, we have repeated inputs with different outputs, right? That's really the crucial part there. So usually, yeah, if we see any repeated inputs here, like in this case 1 and 1, we are automatically thinking, probably not a function, but we should also check and make sure that the instructor didn't pull a sneaky one on us and put the same number on the right-hand side, right? So we have the same input going to different outputs. That's the real problem. All right, but I won't do that to you on like a quiz or something like that and give you repeated inputs going to the same output. That would just be mean. All right, great. Any questions about the first problem? All right, then I'm going to talk a little bit about, one second. Let me make sure I set an alarm so I don't forget to start the quiz later. Okay, that's smart. All right. Then we'll get this out. That's not what I want. Okay, so let's start with slope and linear functions. Okay, so man, I feel like what I should really start with is just a slope, or a linear function, excuse me. So a linear function a linear function can be written in the form y equals mx plus b, where m and b are real numbers. Okay, so remember this symbol means belongs to, and this symbol means real numbers. Okay, so write that little backwards E thing. It just means that m and b are members of the set of all real numbers. Okay, so here y and x are variables and m and b are numbers. Okay? And this equation's graph forms a line. And here the slope is given by m, which can also be thought of as the rise over the run, if you've seen that before, which is also the change in y divided by the change in x. Okay, you might not have seen this triangle notation here before, but this capital delta in mathematics refers to the change in something, okay? So the quantifiable change in a quantity. Okay, so the change in height over the change in width, right? That's basically just rise over run. Okay, and also we could write this as f of x2 minus f of x1, right? That's the difference in height between 2 points, with, and then we divide by x2 minus x1. That's the difference in the width. Okay, and then sometimes people write this in a slightly different way. They write y2 minus y1 over x2 minus x1, right? So these are all interchangeable things that mean the same thing. They quantify how fast is the line going up. Okay, so for example, later on we'll look at these pictures here. So this line here has a pretty steep slope, so its m value would be large in comparison to this other line here has a more gradual slope, right? So its m value is going to be smaller, but still positive, right? If it's positive, we're going up. Whereas the line h has a negative slope, right? It's going down. Okay, so this should theoretically all be review. But yeah, that's what a linear function is, and that is what the slope is. And I guess lastly, I'll talk about the b, right? Because that's kind of the missing piece here. So b is the vertical intercept. Okay, b is the vertical intercept, which means the y value when x is equal to 0, right? And you can see, well, if I took x in this equation to be 0, then I'd get y is equal to m times 0, so that would be 0, and I would just get y is equal to b. So that's why when we plug in 0, we get the vertical intercept. Okay. Anything else I want to say here? I think I'll leave it at that, and we'll take a look at some examples here. Okay, so oftentimes they'll give us a table of values, and they want to know, could this function be a linear function? Okay, and here's what we want to look for in a linear function. The rate of change, let me write this as an extra note here. The rate of change of a linear function is constant, by which I mean consistent over any interval. Okay, so the rate of change of a linear function is constant and consistent over any interval. Okay, so that's what we're going to check when we have a table like this. We want to check, well, if I go from 0 to 100, right, then my rise over my run, my rise was 25 and my run was 100. And what I want to check is this the same over each interval? Okay, that's what I want to check. So the next interval, I went up another 100 and I went up another 25, right? So this is, again, the rise is the difference in the heights, which are given by the g of x, right? And the run is the difference in the x values. Okay, so rise over run. Okay, next up, we go from 75 to 100, so that was an increase in 25 for the rise. And the run was, again, 100. Okay, so one thing we see is that each time we're going up by the same amount, and we're going over by the same amount. So what do we think, linear or not linear? Linear, right? Because it has a constant rate of change. Okay, let's do another one. So for b here, the first one, we go up by 10, right? And we went over 5. And then next, what did we do? Uh-oh, this is confusing. We went up by 6, right? And we went over 3. And then this last part here, 8 to 15, what is that, 7? And we went over 14. I'm sorry, what am I doing? We went up 14, and we went over 7. Thank you for catching that. Okay, so we got different numbers here. Is that a problem?
No, because they all equal to.
Exactly. It's not a problem, because what we said was that the rate of change should be a constant, right? We have all these different numbers here, but these numbers are all the same number written in different ways. They're all the number 2, right? Because if you take 10 and divide by 5, you get 2. 6 divided by 3, you get 2. 14 divided by 7, you get 2. So what we're looking for here is that the ratio of the rise over the run stays constant. Not necessarily the exact same numbers, but the ratio should be the same. Any questions? All right, last one. Here we go, up 20 over 12. Here we go, up 10 and over 12. And then here we go, up 5 and over 12. So what do we think, linear or not linear? Yeah, not linear, because these numbers are not the same. Okay, so those ones are not, that one's not linear. These two are both linear. All right, any questions on problem 1? All right, then let's work on problem 2 in our groups here. Okay, so we're going to start off with the following instructions. So we're supposed to find and interpret the slope and the vertical intercept. Okay, so it takes a little bit of thinking to understand, well, what does the rate of change mean in terms of the problem, right? So we're going to try to interpret the slope, and we're going to try to interpret the vertical intercept, okay, in terms of the examples. So the first one, we got an icicle growing according to an equation, and the second one, we have a cost function based on how much data you use on your cell phone. Okay, so let's work on those in groups, and I'll walk around. Just raise your hand if you guys have any questions about anything, or if you find the problem confusing, and I'll come help out, okay?
Starts at $10, like the base plan, and for every megabyte you use, it adds $2.05, and then all that together is like how much you pay per month.
Like take you out or something. Yeah, I mean,
It was a lot of fun, but like, didn't sleep for 37 hours.
Oh my god.
Yeah.
That sounds wild. I want to do that.
I'm at 8 hours a night.
Yeah, but while you were in it, but like as soon as it's over, we had to go to the airport. I'm like, no, no.
They dropped that.
So bad.
All right, how we doing? Would anybody like a little more time? Has everyone come to a consensus with their group? Okay. That's what I'd like everyone to do with these group problems. Okay, if you're more of an individual worker, you want to work on your own, that's fine. But what I would like you to do is, once you're done, do compare answers with the rest of your group and just come to a consensus. If you find a difference between what you put and what someone else put, please investigate that. See if you can figure out what went wrong, okay? All right. So what do we think for the first one? We've got an icicle growing according to this formula, W of t. Okay, so we're supposed to interpret the slope. So first of all, what is the slope in this case? Yeah, it's the number which is attached to the independent variable, okay? In this case, it's t. It could be x or z or whatever, right? But it's attached to the independent variable, so it's 0.2. And what does it mean in words if our slope is 0.2 for this icicle? Who wants to help me out? Yes?
For every hour that it's growing, the icicle will grow 0.2 centimeters.
Very good. Okay, so t is the time in hours. Okay, so for each hour, the icicle grows. Now, W is measuring the width of the icicle in centimeters. So that's going to go up by 0.2. By 0.2 cm, parentheses, in width. In width. Okay? So that's a perfect interpretation of that part. All right, and how about the slope or the intercept? In this case, our b value is the other number, right? 0.15. What does that mean in terms of this problem?
So it's the initial width of the icicle.
Yeah, and how did you come to the conclusion that it's the initial width?
Because it's the number that does not have a variable attached to it, so it is safe to say that it is the starting point.
Exactly. So if we plug in 0 for t, right, that's how we get the vertical intercept. So in this case, you want to think about, well, what does it mean in terms of the problem if t is equal to 0? Okay, well, remember, t describes hours since the first measurement was taken. So if t is 0, then it's right when we take the first measurement. Okay, so in that case, you could say, you know, the initial width for the first observation, or whatever, is 0.15 centimeters. Okay? Any questions on this first part here? I think the trickier part, okay, is to do the slope. What do you guys think? Similar? Yeah, I think the slope is the trickiest part. So what we want to think about with the slope is what would happen to the number on the right-hand side if we increased the independent variable by 1? Okay, if t went up from, say, 0 to 1, how would the number on the right-hand side change, right? Think about that. And if you think about, well, what does it mean for the time if t goes from 0 to 1? That means 1 hour has passed. And what does it mean for the width if this number went from 0.15 to 0.2, right? Or 0.35, sorry. Okay, so that's a pretty simple example here. And this second one, I think we can easily identify what m and b are going to be. In this case, m is the number which is, again, attached to the independent variable, right? So 2.05. B is going to be 10. And what do we think for the interpretation of these two things? Maybe someone in the back right group? Yeah. So, well, m is going to be our slope, right? So, in this case, m is attached to our n, where n is the number of megabytes, right? So, the 2.05 times the number of megabytes we use is going to correspond to the price per megabyte, I think, in this scenario, right? So this is each megabyte costs 2.05. What is it? Dollars? Dollars. Okay, and then what about the B? Yeah, exactly. Initial charge for the phone plan. Okay, great. So, in other words, you pay $10 per month. Right, this is for just 1 month, right? For an international data plan, cell provider. Yeah, charge in dollars for 1 month of international service. So you pay $10 per month plus $2.05 for each megabyte that you use. All right. That's kind of expensive. Any questions on part A or part B? Okay. If not, then we're going to move on to talk about how to find the equation of a linear function. Okay, and then we're going to have a pretty tricky group exercise. Okay, so let's first talk about two things here. First, I want to tell you about slope-intercept form. Maybe I'll put it over here. Yeah, slope-intercept form. For a line, looks like y equals mx plus b. But there's another important one that we're going to use all the time in this class. It's called point slope form. Okay, and it looks a little bit different. It looks like y minus y naught is equal to m times x minus x naught. Okay, where here the m is the same m from the other equation. Okay, but you'll notice that we don't have a b value. Instead, we've got this y naught and this x naught here. Okay, and those come from the fact that x naught comma y naught is a point on the line. All right, so that's point slope form. Okay, and I'm going to use the next page to talk about how to find the equation of a line using either form. Okay, by the way, while we're in the classroom, please remember to put the mask over your face. It goes over your nose and your mouth. Thank you. All right, so let's talk about how to find the equation with slope-intercept. Okay, so I don't want to put too much text on the screen at one time. But basically, for both of these methods, we're going to need two things. Okay, we're going to need a point on the line, which we will call x naught, y naught. Okay, so that's to differentiate from the variables x and y, right? If I write x naught comma y naught, these are specific numbers, okay? So in a given problem, these will be fixed numbers, as opposed to the variables x and y, which can change their values, okay? So if we look at x naught comma y naught, that's a point on the line. And the other thing that we need is to find out the slope of the line, m. Okay, so what do we do with both of those things once we have them? Okay, well, the first thing to do is to set up the equation in slope-intercept form. That's what I meant to write here. And we are going to plug in our m value. Okay, so once we get the m value, we just write y equals mx plus b, and we're going to replace m by the slope which we have found. Okay, so the slope we find from looking at the problem. If it's a word problem, it may tell us what the slope is, or they may give us 2 points and we got to do the rise over the run to figure out what the slope is. Okay, but once we've got the slope, we plug it in. Okay, so then we'll have something like y equals some number times x plus b. In order to find out what the b value is, we just take the x naught and the y naught and we plug them in for y and for x. And we solve the resulting equation for b. Okay, so let's see an example of what that's going to look like. Okay, so let's say we have a problem and we identify that the slope of this line should be 3, and we know that it passes through the point 1 comma 4. Okay, then the first thing to do is to set up the equation y equals 3x plus b, right? And now our goal is to figure out what is that other number b gonna be. Okay, and the way we do that is we just take the number 4, that's our y naught, we plug it in for y, and then we take the 1, that's our number for our x naught, we plug it in for x, and then we get an equation. We get 4 equals 3 plus b. Okay, if we have 4 equals 3 plus b, then the number b must be 1. Okay, we can find that by subtracting 3 from both sides, right? This 3 goes away, and then the 4 minus 3 becomes 1, so we get 1 equals b. Then we back substitute the b in to our equation. Any questions so far? All right, please stop me if any of this is confusing, okay, and ask a question, because more than likely you are not the only person who has a question. Okay. I'm going to move on to point slope form now. Point slope is way easier. Once you have the two things that you need, the slope and the point, you just plug them in, okay? You put the m where the m spot goes. You put the x naught where the x naught spot goes, and you put the y naught where the y naught spot goes. And then you're done. Okay, so for this example, go back to problem 3. What does that mean? Oh, yeah, thanks. Thanks, me. Okay, so for this example, let's say we had m equals 3 and x naught, y naught equals 1 comma 4 again, right? For this example, all we do is y minus 4 equals 3 times x minus 1. Done. Okay? So this is an equation that you need to memorize. Okay? It's mandatory for this class for you to memorize this equation. It will help you a lot, trust me. It'll be well worth the time that you put into it. So just write it on a flashcard and put it under your pillow when you sleep at night and absorb it through your dreams. All right? Okay, any questions on these first two? Okay, so now our goal is going to be to apply one of these two methods, okay? Whichever method you feel like is your favorite, you can use. Okay, but we're going to work in a group to try to solve problem 3. Okay? We're going to solve problem 3. And I'd like us all to work for a minute or two. And then I might give you a hint. Okay, so let's work on our own or with a group on problem number 3. See if we can solve it on our own first without the hint. And then if you run into some trouble, I'll help you out. Any confusion about this one? What's tricky about it? There's no points, right? But let's take a look at this one. Is there something special about that point in terms of this graph here? That's an intercept, right? Is it a horizontal intercept or a vertical intercept? It is a horizontal. Now, if we have a horizontal intercept, it has a left and right, it has an x value, right, and a y value. If you're on the axis, right, one is going to be 0 to 20. The x value is the height is 0, right? It's on the floor. Think about it that way. So if your height is 0, the y value is going to have an equation involving.
Yeah.
Right? You have an equation
The
involving
one that's down by the middle side is 0, 4 because you just plug in to the equation that's already up there. That
that
equation
can help you get that point. Then after that,
and you just plug in 0 to x because you're trying to find the y-intercept, and then if you plug in 0 or negative 0 squared, which is 0, and then plus 4, so it just would be 0, 4. And for the other one, I did the same thing. I just plugged in y instead. I plugged in negative 1 to y.
Are you sure it's from the one?
Or negative x. I got negative. Yeah, negative 1 times or negative 1 comma 2.
Yeah, okay. And it'd be negative 1. Wait. Log in y, and it's square, so negative x is not.
you can see some points on here.
Negative something else. But I'm not sure.
Let's look at the one on the right for a second. The one that's on X. That's the X-Intercept, right? So what I did is I got now if we're on the floor, right? What's our height?
Once you have those 2 points, you can either do well, stuff that they just talk about what's like the those plug in this formula, but it doesn't actually plug in the other one.
Right? You wait one minute. It's a tricky problem.
Is that the y2 minus y1 or y4 minus 3? And then you can put 0 minus 2
All right, let's come back as a group. I saw a lot of people slowly putting this together. Where the hell is my pencil? Oh, it's in my pocket. Okay. So let's start by just identifying, or let's just all have a moment of honesty. Who thought this example was kind of tough? Okay, almost everyone. I agree. I think this is a tough example. Let's see if we can put words to why this problem was tough. I often find that that's really helpful for me when I'm trying to solve a difficult problem, is I'll look at it and I'll say, I'll struggle with it for a second and I'll say, why is this so hard? And then that will lead me oftentimes to what I should be looking at. So who has an idea of why they think this particular problem was tough? Yes?
Because for the two indicated points, you got a point that had its x but not its y, and the other point that had its y but not its x.
Exactly. So the two things we need, right, to find the equation of a line are the point and the slope. They don't tell us what the slope is. What they give us really is half of 2 points, right? So we don't have a point and we don't have a slope. So we have to do some extra work to find out what these points are. And then we need to use the slope formula to find out what is the slope. And then we'll have a point and a slope and we can move on, right? So this is kind of a three-parter, right? We got to first figure out what these 2 points are. Okay, and that's going to use some other information that we learned the other day, right? Okay, so let's focus on this first point here, okay? So every point has coordinates, right? Something comma something. And in this particular circumstance, they tell us one of these 2 coordinates. Is it the x coordinate or the y coordinate? Yes, the x coordinate, right? This -1 is talking about this point right here, which tells us how far left and right we are, which is the x coordinate. So in this case, the x coordinate we know is -1, but the y value is a question mark, right? But there's actually a way I can find out what that y value is, because I know that that point is on the graph of this parabola, right? So how can I find out what the y value is if the x value is -1? Yes?
Plug in the -1 to the formula above.
Exactly. Points on the graph of an equation or a function satisfy that the x value, if you plug it into the function, you get the y value, right? So what we should do is plug in y equals negative. Now for x squared, we have to put in -1 quantity squared plus 4, okay? So in this case, what we have to do is we have to take the number x, we have to square it. This is PEMDAS, okay? E comes before M, and then the minus, right? So we have a minus 1 squared. That means negative 1 times negative 1. That gets us a positive 1, and then it's negative. Okay, so this is a negative 1 plus 4 is equal to 3. So in this circumstance, this point is negative 1, 3. Okay, are we ready to solve for the equation of this line? No, we have a point. What's still missing? The other point. And what do we really want the other point for in the end? To be able to find out what the slope is. Okay, if we have 2 points, we can find out what the slope of the line is. So we also have to figure out this other point here. Now, there's something kind of confusing about this one. They don't tell us what the x value is or the y value. Or do they? Do we know one of the x values or the y values here? Yeah, Eric?
It's the X-Intercept of the parabola equation?
Yeah, it's the X-Intercept. Or the Horizontal Intercept. Okay, and the horizontal intercepts are special because they lie on the horizontal axis. And we know something about all of the points that lie on the horizontal axis. What do they all have in common? Y is equal to 0. Very good. So we actually do know that this y value is 0. So how do I figure out what the x value is? Well, I'm going to use the equation again. So in this case, I'm going to let 0 equal negative x squared plus 4. Okay, and then I'm going to move x squared over to the other side. And I get x squared is equal to 4. And then that tells me that x is equal to either 2 or negative 2. Well, shoot. I got 2 answers. I wanted 1 answer. How can I select between positive 2 and negative 2 for this x value? Yes, in the back?
It's in the first quadrant, so it has to be positive.
Yeah, or maybe not in the first quadrant per se. First quadrant would just be everything that's
Yeah.
up here. But yeah, I get the point. It's on the right, right? It has an x value which takes us to the right. It's on the positive x-axis. Sometimes that's what they call that, right? So if we move to the right, we know the x value should be positive, so I can get rid of the negative solution. I'm not going to worry about the negative solution. It's just going to be x is equal to 2. So this is the point 2, 0. Aha. And now, finally, after all of that prep work, I can go ahead and try to solve for the equation of this line, right? So there's one more thing I need. I've got 2 points, so I have an excess of points. What do I not have? The slope. So what I do is I find the slope by doing rise over run, okay? So that means I take the second point. 0 is the y value. I subtract from that the y value of the first point, which is 3. And then I divide that by 2, which is the x value of the second point. And I should subtract from that the x value of the first point, which is negative 1. Okay, so in the end I get, this is my slope. So this is going to be negative 3 divided by 3, or negative 1. Okay, so now I have a point and a slope. So I can use point slope. So I'm going to choose the second point. So y minus 2 is going to be equal to our slope, which is negative 1, times x minus x naught. Ooh, sorry, x naught should be 2. What am I doing? Yeah, there we go. So y minus 0, that's my y naught. Okay, so this is my x naught. That looks like a y naught, doesn't it? Okay, let's be good. X naught, and this is my y naught. Okay, so I'm plugging in here. The x naught goes where the x naught goes, and the y naught goes where the y naught goes, and the slope goes where the slope goes. Okay, and then we get our equation. So if you did it in point slope, it would look like this. If you used slope-intercept, it would look like y equals negative x plus 2, right? You distribute that negative 1. Okay, so this is fine. This is fine. There's one more that would be fine is if we use the other point, right? It'd be y minus 3 is equal to negative 1 times x plus 1. Okay? Any of these three would be sufficient answers for this problem. They all actually describe the exact same line, because all you do is just rearrange them, okay? For this one, I distribute the negative 1 onto both of these, and then I add 3 to the other side. If I did that, I'd get back to my slope-intercept form, okay? So all of these equations, they're not different. They're just the same one rearranged in different ways. Okay? All right, any questions on this problem? Oh man, it's 2:13 already. Jeez, I'm going so slow. Okay. Well, let's see, what else did we have? Okay, well, we pretty much made it through what we needed to. All right, so we're done with 1.2 pretty much. We're going to start the quiz now, so please move your desks back into regular mode. Yeah, question? So you either need to do 0 minus 3 and then 2 minus negative 1, or you'll have 3 minus 0, which makes the top 3, and then the bottom would be negative 1 minus 2, which makes the bottom negative 3. Right? So if you do negative 3 over 3, you're doing 3 over negative 3, right? You get negative 3. All right. So please put everything away except for a pencil. We're going to do a quiz now for 15 minutes. Okay, so once you're done with the quiz, you can just come to the front of the class and turn it in. Please leave it face down on your desk for the time being, and we'll all start at the same time. 3, 4, 5, 6, 7. Put those face down on your desk for the time being. Okay, before you start the quiz, one thing I forgot to mention earlier. Oh, you don't need one, do you? Yeah, whatever, it's fine. Okay, so one thing I forgot to mention is the quizzes, okay? The problems for the quiz always come from, well, one of them will always come from the quote-unquote extra problems, okay? So you'll see on each section there will be an additional problems section, okay? If you study those problems, you'll get at least one of the questions on the quiz right. Okay, so the quizzes from here on out are going to be drawn from this. So this is an incentive for you to do the extra problems at home. Okay, I'm not going to do them in class, but they'll be helpful for your learning. Okay, you may start.